All right, now here is our last page of review. So let's go ahead and see what we got. So 41 through 45, the last four questions here, are about the graph of this p of x, which has rational coefficients, and it's a fifth degree polynomial shown below. So it's this guy. And so right away, some things we want to make note of here. It's fifth degree, so there's five solutions to it. And right here, this is our x-axis, and this is our y-axis. And we can see that one of the solutions is right where I've drawn that arrow. At -3, outcomes is 0. Right here, there's that touch and then turn away, so this is a multiplicity going on here. So that's 4 is a solution and 4 is a solution again. So it happens twice when that occurs. And so we can see that it must have at least 3. This could maybe have a multiplicity of 4. But usually those are a little flatter right here. Let's see. At most, how many imaginary zeros does it have? Well, if we assume that this is only multiplicity 2, then at most it could have 2 imaginary solutions. Because remember, it has to have 5, so if this is 1, 2, and 3, the other 2 must be imaginary. Now, if this was multiplicity of 4, so this occurred as a solution 4 times, then it could be no imaginaries. But they wanted at most how many? So the most it could have is 2, or at most 2. Let's see, 42. Identify the local maxima and minimums. All right, so I'm going to zoom in here. So here we have a local maximum and another local maximum. They just have to be the highest point in a little region here. So this is a local max and a local max, and this would be a local min. So we've got a local max right there, a local max right there, and then we have a local min right here and right here. So let's see here, identify the local maximum. So for maximums, we could give the ordered pair -2.0 and 5. You get the idea. I'm a 181.78. That would be one of the local maximums. And then 100. It's a nice one. That'd be another local maximum. Should have done those in pink to line up with what I circled here. And then the ones in green, those are your local mins. So we have a local min at 0.48, that ordered pair, and then again at 4.0. Describe with inequalities the x values for which p of x is increasing and decreasing. So here's our polynomial. Remember, we just read left to right. Here it's increasing because it's got a positive slope. Now it's decreasing because it's got a negative slope. No, it's increasing. No, it's decreasing. No, it's increasing. Okay, so we want to do increasing first. So I'll just highlight the increasing parts. And then it turns around right there. And it starts to increase. Then it starts to increase. And the points that help us identify this or describe it, it says describe these regions with inequality. So right here, it's increasing. Even the parts we don't see, it's just going uphill this entire time. And it does that until it looks like right about there at -2. Because at -2, it turns around. So when the x is less than -2, it is going uphill. It's got a positive slope. Then as soon as it gets past that -2, it starts to decrease. And now it's got a little region of increase. So we got to look at the x values here. It starts increasing right here when x is 0, and then stops increasing when x is at 2. So we'll just trap our x in between those two values. And then we got one last region where it's increasing in this section over here, and that starts at, that's right at the 4. So that's as soon as you get x is greater than 4, it's also increasing. For the decreasing portion, I'll highlight those in blue. So decreasing right there, that's between -2 and 0. Decreasing right there, that's between 2 and 4. And so that's what we write for the decreasing part. For decreasing, we'd say it happens between the -2 and the 0. And then it's also decreasing between the 2, your x in the middle, and the 4. So this is our increasing intervals, and this right here, those are our decreasing intervals. Should have put them down there where it's asking the question. Let's see here, number 4, describe with inequalities the x values for which p of x is greater than 0. So I'm going to erase a little bit of this, and then we'll try and figure out where the heck it is greater than 0. So when they say the values of p of x, what they are talking about is the y values. And so if we think about it, here's my x-axis right there. And if you're above it, these are positive y values. You can even see them here, 50, 100, 150. So any y values, any of the points up here, these are all positive or greater than 0 y values. Now, back to everything between -3 here and this 4, everything is positive. And then right after the 4, it's positive again. The only places it's not positive is right here to the left of the -3, because it starts to go down here. And then it's not positive right there either, because right at that point, you can see it equals 0. So to describe where it is positive at, we will say it is from -3 all the way to 4. And actually, we can really write this, because since every value of x bigger than that -3 there, these give you, all of these x's give you positive values. And so the easiest way to write this one is just to say, hey, if x is greater than -3, comma, and x does not equal 4. That'd be a real simple way to write that inequality, because every x value greater than -3 works, except for the number 4, because that's where it equals 0 at. Let's see, where is it greater than 0? Describe with inequalities the x values for which p of x is greater than 100. This is kind of a neat little question here. If you look at this graph, here's where y is 100. This is the mark where p of x, right there, you equal 100. And so they're asking for describe values when it's greater than 100. Oh, so it's a very similar problem that we just had. So let's see here. When am I bigger than that 100? This region is all higher than that 100 line. And this region is higher. And so I just say, well, the function p of x will be greater than 100 when x is trapped between, and I got to find out these numbers right here. That looks about like -2.9, something like that. And let's see here. This point right here, I can tell that's right at -1. So -1. So in that little region, this little envelope right in here, those x values showing up down here, those are the x values that get you above 100. And then right here, as soon as your x goes past whatever this x value is, you're also greater than 100. So I'm just going to drop a line straight down to try and get a reading on my x-axis. it's a little bit short of 5. We'd call it maybe 4.8. So when x is also greater than about 4.8, it is also positive. Now, of course, on our final, these things will they'll be easy to read, and it's also multiple choice, so you should have no problem, hopefully, if you understand it, picking out those solutions. And I think that wraps up all those questions. Ran out of a little room for those bottom ones, but we covered them up here in the video.